Okay, so today we're going to start chapter 3 and looking at the concept of parallel lines, and then also the angles that are formed when we have parallel lines that are intersected by a third line, which we would call a transversal. And so over here in the picture we have two lines that are parallel to each other, L and M, which means they're in the same plane and they do not intersect. Okay, it's possible for two lines to not intersect and also not be parallel. So I'll give you an example of that. You can see in this three-dimensional box figure over here. Okay, if we look at AB, for example, there's several segments it's going to be parallel to. It's going to be parallel to FE. Those are parallel lines. They're not going to intersect each other. It's also, you'll notice, parallel across here to CD. Okay, those are parallel lines. Now, if we look at for example, comparing AB to this line right here, DH. Those two lines are not going to intersect, right? DH is going to go straight up. AB is over here on the other side of the box. They'll never intersect, but they're also not parallel because they're not in the same plane. When that situation happens, we call those pair of lines like that skew. So I'll give you another example of a pair of skew lines. So we look at, let's observe this segment BC. And knowing that line would go on infinitely. And over here compared to segment AE or line AE, if both of those continued on infinitely, they would never intersect, but they're also not parallel because they're not in the same plane, and we call those skew lines. Okay, so we have parallel lines and skew lines. Just to start, we want to be able to picture what they look like. So in our first set of exercises, we just want to get used to looking at things in 3 dimension to be able to picture parallel lines or skew lines. So the first question draws our attention to plane OPT, which is over here. It's the, suppose, like right-hand side of the shoebox. If this were a shoebox, let me keep P open there so we can see the letter P there. So that's plane OPT. All planes that intersect it, I'll draw them in blue. Okay, here's the first one. We could talk about plane MNO. Okay, or you could use the letter P to represent that. MNO. It's one plane that would intersect it. Over here, we'll call this RPS. That's going to intersect it, right? Now let me erase so that you can see the other two. It might be hard for you to see them. So I already shaded those. So the other one that would intersect this would be the bottom of the box. See it down here? We could call that T. I want to shade in the part that's already red, but that would be like TRU or TSU. Any three of the four letters on the bottom there, so we could call that STU. Okay, and then finally over here, this other side here, that would be plane NOT. So the order that we name the letters doesn't matter as long as we pick 3 letters that are in that plane. Okay. The next question says, all segments parallel to NU. So let's look at where NU lives. It's right here. See if we can identify all the segments that would be parallel to it. Well, I've got this one here, MR. Okay. I have this one here would be parallel to it, PS. You see how they're parallel? There'd be like a plane cutting across there. And then also this segment OT. All of those would be parallel. Okay, and then lastly, we want to talk about all segments that intersect MP. So let's look where MP lives, right here. So what are all the segments that would intersect that? Well, we'd have PO for surely does. PS, certainly going to intersect it. We have this segment here, MS. It's going to intersect it. We have segment MN is going to intersect it. And then we also would have segment MR. Those are all drawn and shown to be intersecting MP. So now we have one final box we're going to look at, and this can get pretty busy here. This is, looks like we have a hexagon as the face, so this is, we would call this a hexahedron. It's a 3-dimensional hexagon, has 6 sides on that face. So all segments parallel to QX. Let's see if we can find all of those segments. Well, I know RA is going to be one of them. So we'll label them in blue. So let's look at RA. It's going to be parallel to it. I think this segment here, NE, would be parallel to it if we look closely. Yeah. And he's definitely going to be parallel to it. This segment here would run parallel to it. That's MH. TO is across, would run parallel to it. These can be a little bit tough to see in 3 dimensions here. And then I think SG would also be parallel to it. Right? They would never intersect each other, and we could connect them with a plane. Okay, so let me erase a little bit on my drawing here. Now I want all planes that intersect plane MHE. So let's identify where MHE is. That would be this top plane up here, sort of the ceiling. Okay, so hopefully you can see there's really 4 sides to this plane. So we ought to expect that we'll have 4 planes that are going to intersect it. We can see right away this plane here is going to intersect it. It's the front of this hexagonal hexahedron. So 3 letters that would be on that would be like OGA. So we could name that plane. We can see this one here, MOT, is going to intersect it. Okay. Over on the other side here, it's going to come up and intersect it. That's NEX. And now probably the hardest one to see right now is kind of behind it, right? This back plane here. That's going to intersect the top of this. See it back there? It's also a hexagon. So 3 letters that would live on that back plane back there would be like SRQ. You see this here, SR to Q. And then we could fill in that plane back there. Now, the last 2 that would intersect it is hard to see because we don't see them intersecting in here. You have to remember that these planes go on infinitely. So this red area that I'm shading is going to go all the way out to the left, all the way out to the right, all the way forward and backwards. So same thing as this plane here. This plane here is going to keep coming up, and they would eventually intersect each other. So TSG or TOG would be another plane that would intersect it, as with this one over here, QRX. So a lot of planes that will intersect that, because we have to keep in mind the definition of the plane is that it keeps on going. This is going to keep on going, this is going to keep on going, and sure enough, they would intersect out there. Okay. All segments parallel to QR. So let's identify where QR is and see if we can find all the segments parallel to it. QR is here. So can we see that XA would be parallel to it? Okay. Also parallel to QR would be MT. These are a little tough to see. And then HO. So I only see those 3. Now, last question here. All segments skew to AG. This is a harder concept to picture. You have to be able to really see in 3 dimensions. So here's AG. We can see like SR would be parallel to it. HE would be parallel to it. But when we're talking about skew, we'd be talking about a segment like this, where these 2 lines would never intersect each other, but they're also not parallel, right? How about this one over here, since it's parallel to it? Right? These would keep on running this way, and they would never come down and intersect that line. So basically, any lines that would be parallel to those lines that I already named, these would all be skew lines to this line GA. Right? You can see SR would be parallel to it, HE would be parallel to it. So that's 4 segments right away that would all be skew to AG. We have TO, we have MH, we have NE. And keep in mind, I'm not going to ask you to name everything that's skewed to one particular line, but I want you to just be able to identify what we mean by skew lines. So now let's see if there's any more skew situations for this segment that maybe we didn't see right away. So we had those parallel segments, but what about over here, QR? That's never going to intersect GA. It's going to keep on going. So they would be skewed to each other. which also means TS would be skew. They're never going to intersect if they continue to extend. And then we'd also have MT and NQ. They would be skew. So you can see in this picture, there's quite a few that we can find in these three dimensions there. Okay, and the last thing we're going to talk about, and we'll answer some of these in the Edpuzzle as well, these angle relationships. Okay, so when I have two lines, now notice M and N are not parallel. What's going to happen is we're going to have some very special relationships when the lines are parallel. We'll dive deeper into that in the next section. Right now, M and N are clearly not parallel, but there are certain angle relationships that are formed. First of all, when I'm talking about the lines M and N, I want to think of all four of these angles, angle 4, angle 3, angle 5, and angle 6, as interior angles. Okay, so anytime I look at those, they're in between the two lines. Mr. Blaylock likes the example of a sandwich where they put the toothpick in it to keep it together, and I think that's a great analogy or picture for us. But those are on the inside of the sandwich. Those are in the interior of those angles. When we talk about exterior angles, we are talking about angle 1 and 2, angle 8 and 7. They're on the outside. They don't live inside the two lines. So they're exterior. Right? So that's the first thing when we talk interior or exterior. Then we want to think about this line here. Here it's conveniently labeled with the letter T. It won't always be labeled T. But a line that crosses both of the other two lines, we call that a transversal. Okay, transverse, trans means to cross. So just think of it that way. This line crosses both of those. It goes from one to the next. It's sort of the toothpick in the sandwich. Okay, so now we want to talk about alternate interior angles. So when I look at, and they would come in pairs. So angle 4 and angle 6, they alternate sides of the transversal and they are on the interior. So we call them alternate interior, right? As with angle 5 and angle 3. They live on the interior and they alternate sides of that transversal. They're alternate interior, okay? Then we have exterior angles, right? Well, angle 1 and angle 7 are alternate exterior angles. And then we have angle 8 and angle 2 are also alternate exterior angles. Now, we can also finally talk about same side exterior, okay? So you have same side exterior would be 1 and 8. They're on the same side, and they're also on the outside, and 2 and 7. Okay? And eventually, again, we'll have relationships with them. Now, notice that these 4 angles here are kind of situated in the same positions as these 4 angles here. So what we say in that situation is if we're comparing angle 1 and angle 5, they are on the same side of the transversal, but we don't call them same side interior exterior because 1 is on the exterior, 5 is on the interior. What we call these are corresponding angles. They just live in the same position, right? 1 is in the top left, so is 5. Angle 2 and angle 6, those are corresponding angles because they kind of live in the same positions. Okay, so let's take a look at this drawing that we have here, this sketch, and see if we can identify those angle pairs from the picture. Now, this picture gets a lot busier in a hurry because you have a pair of parallel lines. So you have N and L that are parallel, so those would be your lines. And then you have 2 transversals. P is a transversal on N and L, and so is Q. But I could look at it the other way as well. I could look at PQ as the line pair. It's not parallel. And then N becomes a transversal, or L becomes a transversal. So we want to be careful how we'll identify these angles based on what's happening in the picture. So angle 10 and angle 16, let's lock in on where they live. So 10 and 16, N and L is going to have to be our line pair, okay? And Q becomes a transversal. It's the only way that we can see that these 2 angles would be related to each other. They're both on the exterior. Okay, so what we say in that case, they're on the exterior of N and L, and they alternate sides of this transversal Q. They're alternating. So these are alternate exterior. Okay, 4 and 12. Let's see where they move us for 4 and 12. We might have a different transversal situation here. So here's 4. And here's 12. So now PQ becomes the line pair and N is the transversal. And notice 4 is on the exterior of that situation. 12 is on the interior. So they're doing different things, but they're in the same position. So these are called corresponding. So this is a situation where we would call these corresponding angles. Okay, 12 and 13. Let's look at where 12 and 13 live in relationship to each other. So now that the line pair is back to N and L, Q is the transversal. They're both on the interior, 12 and 13. So they're not in corresponding positions, but they're on the same side interior. So we would call those either consecutive interior angles or same side interior. Okay. Sometimes the same side is helpful for remembering some of the relationships, or we say same side interior. Either one of those, you'll see them go back and forth in labeling those. 3 and 9, let's see where they are. Okay, so now PQ is the line pair and N is the transversal, and we can see both of these are on the interior and they're alternating sides of that transversal. So these are alternate interior. So here are the exercises, just going to be able to name the transversal. So when I'm looking at 9 and 13, the transversal in that situation is going to be Q. Right? N and L are the lines that are being transversed by Q. 5 and 14. Here's 5, here's 14. So P and Q would be the line pair. The transversal in that situation is going to be L. Okay? And then finally, angle 4 and angle 6. We have 4 and 6. They're alternate interior, but they're not asking for that. You just want to know what's the transversal, and it would be P.